Hello, I'm Li Hao. Welcome back. We've been building client-side routing library with Svelte for the past few videos. If this is the first video you're watching, then don't worry. I've attached the link in the description, the link to the playlist for all the things that we've done so far. Just watch them and you will be able to catch up with us. So let me do a recap on what we have talked about so far. So in the past few videos, we've been working on our script to generate a file-based routes definition. So we analyze the folder structure and then we generate a routes definition file. And with that file, we've been able to use that file to do a client-side routing, right? So we've started with a client-side routing library first, then we've moved on to just focus on the script. And basically, this script has almost like 95% done. We've able to solve most of the features, able to give like the dynamic parameters, REST parameters, able to handle layouts, be able to do a parameters matching. And one thing we found in the last video, one slight little bug is that sometimes when you define some routes files that is supposedly to be more specific. Like in this case, we have A, B, and A rest routes, A/B and A/rest with 3 dots. Then we realize that it always match the A/rest routes is always used to handle any URL, even with A/B. And we found that it's because in the routes definition that we generated, A/B comes after A/rest, and therefore the first one because the first one is a superset of the A/B routes, so we always match with that route. So we're gonna fix this issue by figuring out how we can sort the order of the routes in the file that we generated, right? So we will need some algorithms, some sort of ways to figure out which one is what we consider as more preferred or higher specificity or higher order. And we sort the routes based on that criteria, so that later on when we generate the routes definition, they are ordered in the correct order or the order that we want. Sounds good. So let's jump in and see how we can do. Sorry to jump in, but I got an important thing to tell you, which is that if you're following along, coding along with me, the code for all this is on the GitHub repo. Link in the description. Just follow along. If you miss any steps, each changes are in individual commits. So you can just check out that commit and take a look at what you are missing. Now follow along. So first of all, we need to define an order. If you come over here, get some inspiration from the svelte-kit docs, you can see that in svelte-kit, in the advanced routing section of sorting, it actually says that how it sorts the routes and according to the following rules. So if it's more specific, it is higher priority, right? So more specific, which means if you have less dynamic stuff, then it's higher priority. Endpoints, we don't have this, so we can ignore. With matches are higher priority, without matches. Rest is the lowest priority, and ties are resolved alphabetically. Right, so this is the order where you get this. This is more specific than everything else, right? Because this has more static part of things, and this is more just fully dynamic. And rest is the last one. Right, so we're gonna add some ordering in our routes definition. So let's take a look at the code that we have so far. The generate routes script. Here in explore folders, we explore all the files and folders, and files, and we extract all the routes in this array. So in here, we apply layouts to each of the routes, and we extract the regex and params pattern from each of the routes. And I guess here what we need to do next is to sort the routes. So we can use the inbuilt sort function, routes.sort. Basically, it's a built-in function from in JavaScript, which is the array.sort. So this is an array, and it takes in route A. It takes in a function, a callback function. Sorry, that has two parameters, right? You can call it I or J or A or B, but basically it's the first route and second route. And this function, this allows us to customize the sorting algorithm to decide which comes first or which comes later. So this function, if we returns if we returns 1, which means that A is greater than B, which means A have to come after B. If A has to come before B, then we have to return -1. And in the cases where we can't decide, right, then we return 0. I think this is a very rare case for us when we do sorting, because you can't really create two files in the same place, right? So the file name will always be different, and different file names will definitely be able to figure out who comes first or who comes next, because ties are resolved alphabetically. So let's figure out what we should return. How do we write this routes function? So once we figure out this, and then I think everything will just figure out its own, because this is still the same routes array, and this does sorts in place, so which means that this array will be updated and mutated. And so since the rest of the things we figured out already, so let's just focus on the sorting algorithm over here. So over here, when we do sorting, I think we need to look at section by section. If the section that comes, say for example, if you have routes, right, say A, B, and versus like say A and B, I feel like this is more specific. At least this is what I decide, that this is more specific. So this has to come before this thing, right? This is more specific. So we have to look at section by section, and we determine whether is there any dynamic stuff within the section. So to do that, let's see. I think here in get regex, we kind of already split by sections. Maybe we can return that or extract some of that information out. So segments. Let's see. Segments. Okay, I'm gonna create an array called our name here. I'm gonna maybe call parts, and parts is gonna push in each segment. So segment itself is the string, and okay, so here I'm gonna have a part like this, where this segment is that original string that we have. And later on, we also will add, say, information like if we encounter a res, the segment itself should have, we should say let's see. I think we can do all this in the closing bracket. It's much easier here. Match the params. This is where we push the params. Also, we should come over here and say the part dot if res, then we're gonna mark part dot res is true. We also say if we have match, then if match then part dot match equals to true. Right, so the part has the segment name. It also has the res, the match, and also maybe we get at the params, right? No, I think we just say it's parts is dynamic equals true, right? If we have this segment is dynamic, so we get the parts here. Oops, sorry. Hold on. In this segment, we have a parts. Then we're gonna also push this parts. Stop push parts. Okay, so we're gonna return that parts over here. So we're gonna use some information. So we extract some information over here already. We figure out whether it's an array of segments, and these segments we also store whether this segment is dynamic, whether it has rest, or whether it has like matcher, right? And we use this if, right? It's because if we set it to true and it's always be stay true, we don't set it to false. So if you have multiple params, one of it has matcher, then we just consider that as a higher specificity. Like, of course, if you want to really compare, like count how many params that has matcher, if you have 2 and only have 1 routes with matcher, those kind of scenario, well, let's just ignore this for now. You can figure this out logic, but yeah, so I'll just give you a high level idea of how you can implement like a sorting with at least consider that whether it has match or not, right? So this returns a parts. So here we have parts. So we can assign the routes parts equals to parts as well. And here with these parts, we can console out the route A parts and route B parts, right? Before we start. So let's kill this. Let's try run this. So a parts is an array, right? So we have shop ID, and this is dynamic. We have item, this is dynamic. Here you have dynamic and matching. The dynamic. Then you have this is the segment, and this is rest is true, right? So now we can just compare one by one to decide whether this parts of these routes is a higher priority or should come before this one, right? So of course these are arrays, so we're going to compare array one by one. So I'm going to call this parts A equals to this one, and parts B equals to routes B's parts. I think first of all, if parts A dot length is longer than parts B dot length, or rather if it's different, then we can actually know that a longer segments should be more specific, right? Even if you match this, if you're able to match it together, the longer the route segments it is more specific, right? So how do you even get matched, right? So in this case, probably you get say something like A slash rest versus A slash B slash C. Then even if you have a lot of things here like A and B, this has length of 3, this has only length of 2, then this is more specific, right? This is longer, then this is more specific. So if it's different length, then we can immediately know which one is more specific, right? So return if parts A dot length is shorter than parts B dot length. If this is shorter, then it should go after, right? So A should come after B. So return 1, else return -1. Okay, so if now all the parts are equal length, then we can loop through that I equals 0, I less than parts A dot length, and I plus plus. Okay, and now we're going to check So the lengths are the same, so we don't have to worry. So now the part A equals to parts A, I. This is part B, which is the part B. So we don't have to worry that we are accessing something undefined because they are equal length. So part A and part B, let's compare. So if part A dot say, so part A, if this segment, if one is dynamic, one is not, right? So if part A dot dynamic is not equals to part B dot dynamic, then immediately we can know that we can already differentiate which one is higher priority, right? Because one is dynamic, one is not. So if it's one is not, then return, can return immediately, right? Return if this is dynamic, and it should come after, right? This is 1. And if not, then this is static, then B is dynamic. So A should come before, which is -1. Okay, next. If both are dynamic, let's check if A has match and B does not have match. So match is a boolean, true or false, right? If A has match and B does not, then return part A. If you have match, then you should come in front, right? In this case, since they are different already, so if A has match, then B must be does not have match, right? So if you have, then B does not, then you should come in front, something like this. Okay. And also we also have this thing called a rest, right? If one has rest, one does not, then part A dot rest, if it has, then it should always be at the back. If it does not, then it's in front. And we go through each segment, right? We go through each segment. If it's static, then we don't really care. One could be before another, but if it's something like this, then we go through each one, and we should be able to figure out the whole thing. But if in the end we still couldn't figure out, I think we can say the tiebreaker is the alphabetical order. So return if say the route A dot A, let's see, route A dot the name, relative path, I think, right? Relative path. Just compare alphabetically. If it's less than route B dot relative path, well, less than, when you compare string less than, which means alphabetically it's before. So if it's before, then it's -1, and this is 1, right? Okay, let me comment this out. So we have basic sorting, and let's try and run and see how it turns out in the end. So we've generated our routes definition. Let's format this nicely. So this comes first. Okay. This AB. Okay. Yeah, I don't really know like why this comes first before AB, but it doesn't matter. It does not match the same route. But we have AB. Wow. Okay. AB is here, but then the one with the rest is behind. So at least we match AB first and match this, right? So let's take a spin. Let's start the server. npm run dev. Let's try and come over and visit our page. So if I go to A, B, C, D, E, then it's the rest route. But I go to A, B only, it's empty. Well, that's because in our B, let's see, where's our B? Right, hold on. Give me a moment. A, B, this is empty, so this is A, B. Save this. This is the A, B. And if we have, I think here we do have some with parameters matching, some does not. Then let's take a look whether they are in correct order. So this has matching, and this does not have matching, right? So this does comes before this one, which is correct. which is correct. Yeah, so I guess we've able to sort our routes, we're able to order our routes, and this way it is more deterministic on where you have a more specific routes always comes or be matched before a less specific routes, rather than based on how we explore our files and find them, right? Because we extract all the file routes before we sort. I believe the files are sorted out alphabetically somehow based on your file system, just your operating system, file system, whichever that returns first, you get that route. But now we sort it based on our heuristics so that we get the more specific routes always be matched before less specific ones. I guess this wraps up the whole file-based routing that we have. Let me think what we are lacking. I feel that we can do one more video about a named layouts, right? So layouts right now, we just search all the layouts that we have in our, we just use a layout file if we have, but we can actually add names to the layouts. We'll call a name layout so that you can selectively choose which layout file you want to use. Sounds about right. So let's see you in the next video. Of course, remember to subscribe so that you get notified when the next video is out. So see ya, bye bye.